Up YouTube, welcome back to the channel. My name is Manny, and in this video we're going to be doing a couple of examples on exponents. If you haven't watched the previous video where we discussed the different types or the different laws of exponents, please go back and watch that video. If you already know your laws of exponents, you can continue with the video and hopefully you can keep up with us. So without further wasting time, let's get straight to the video. So we have a couple of examples. So the first example says a to the power of 3 over 3, all this raised to the power of 2. What's the answer? So we obviously need to evaluate that, right? So in this type of situation, there is a law that we discussed. I forgot what law it was, or what number law it was. But in this situation, what we do is we say a to the power of 3, and then we take that exponent which is outside, multiply it there. We multiply that exponent, and we also do the same with the denominator. So obviously this was 3 to the power of 1, and we're going to multiply it with that 2. So the value of that will obviously give us a to the power of 6 all over 3 to the power of 2. And if you really wanted to write or evaluate 3 to the power of 2, that will be a to the power of 6 all over 9. So that will be your final answer. So in the next question, we have a to the power of x multiplied by b to the power of 3 minus x all over a to the power of minus x plus 1 times b to the power of 2, right? So here we obviously have two different types of bases, right? We obviously have two different types of bases. So how we solve this one in many cases, since these are variables and not numbers, we solve them according to grouping bases, or we solve them based on grouping bases, right? So in this case, I know that a to the power of x is divided by a to the power of minus x plus 1. And same applies to b. b to the power of 3 minus x right here is divided by that. So that's how I basically solve that. And we know that with our second law, if we are dividing powers that have the same base, we subtract the exponents. So we're going to do that with a, right? So we're going to say a to the power of x minus, and here we're going to put a bracket because it's two terms, it's not one term. So we're going to say minus x plus 1 multiplied by b to the power of 3 minus x minus 2. So the reason I don't put a bracket there is because at the base, it's just one term. The exponent is just one term, right? It's just 2. So now if we clean this up, what we're going to get is a to the power of x plus x minus 1 multiplied by b to the power of 3 minus 2. That gives me 1 minus x, right? So that's it. Are we done? No, we still need to add these two like terms here. So that will give us a to the power of 2x minus 1 multiplied by b to the power of 1 minus x. So I'm not sure if your teacher will probably want you to expand this further, but I'm sure this will be sufficient enough to basically get the full marks. So let's do the third example. So okay, here we have our third example. We have 5 to the power of 2x minus 3 multiplied by 5 to the power of x all over 2 multiplied by 5 to the power of 2x minus 6 multiplied by 5 to the power of x. So this is a bit different compared to what we've already discussed. Here we have 4 terms, and the reason why I say we have 4 terms is because these terms are not separated by a multiplication sign, they're separated by a subtraction sign, right? It could be a plus sign or a subtraction sign, either way. So in this case, they're separated by a subtraction sign. So how do we go about solving this? So when we solve exponents in many cases, what we need to do, our first step would always be having to break down our numbers or values into their prime factors, or into their simplest form, into their prime factors to say. So what I mean with that, I know that 5 to the power of 2x can also be expressed as 5 to the power of x multiplied by 5 to the power of x, right? So I'm going to write it down like that. And on the other side, I know that 3 is already into its prime form, and 5x is obviously already into its prime form. Okay, so at the denominator, 2 is already in its prime form, and obviously 5 to the power of 2x can also be expressed as 5 to the power of x multiplied by 5 to the power of x minus, and with the 6, instead of me writing 6, I'll say 3 multiplied by 2 multiplied by 5 to the power of x. So what this does, it allows you to see all the values into their prime form, and you can also factorize from looking at them in this situation, right? You can also get to see the common factors that lie between the terms and take out the common factors, and maybe something will cancel out. We'll see, right? So in this case, if we look at the numerator, we have 5 multiplied by x multiplied by 5 to the power of x multiplied by 5 to the power of x minus 3 multiplied by 5 to the power of x. As I already said, we have two terms because they're separated by a negative sign. So from the two terms, the common factor here would be 5x and 5x. So I'm going to try to factorize that and leave what's remaining inside the brackets. So if I factorize that, I'm going to have 5 to the power of x, and on this side, I'm going to have 5 to the power of x remaining minus, and on the other side, I'm going to have 3 remaining, right? So I'm going to try to do the same on the denominator and take out all the common factors. So from the first term, I have 2, and obviously in the second term, I have 2. I also have 5, and on the second term, I have 5, right? And obviously, those are the only common factors that I could find. So I'm going to take out 2 multiplied by 5 to the power of x. Sorry, it wasn't 5, it's 5 to the power of x. And I have 1 remaining, which is 5 to the power of x. And I have also the 3 remaining, right? So now, if you look, I have common factors that are able to cancel out from numerator to denominator. So what I mean is this. If you look, what I have here is I have 5 to the power of x minus 3, which is this, and can cancel out with 5 to the power of x minus 3 at the denominator as well. And here I have 5x that can also cancel out with 5x. So what I have remaining on the numerator, if everything cancels out, I just represent the numerator with 1. And on the denominator, I have 2 remaining. So this is my final answer. So let's go through all the steps again. The first thing when we're solving exponents, we always have to try to break down everything into its prime factor. And when we break down everything into its prime factors, if it's terms separated by a minus or a plus, we can always try to find out what the common factors are and take them out and factorize, right? And in this case, that's what we did. We took out the common factors, and from taking out the common factors, what's remaining, we see that it's kind of the same thing, and we can cancel out in that situation and have 1 over 2 remaining. So those are basically the steps that you need to take in solving mostly exponential equation and expression. So we're going to try to do 1 or 2 more examples, and that will be it for this video. Okay, so let's look at another example. Here we have 9 to the power of 1 minus n multiplied by 5 to the power of n minus 1, all over 10 to the power of n minus 1 multiplied by 27 to the power of 1 minus n. So now, let's look at this. As I said, the first step in solving exponential expressions or equations, it's always to try to break numbers or every value into its prime factor, right? So 9, we know it's not already in its prime factor. We know that the prime factor of 9 is 3 to the power of 2. And what was in the exponent, now we put it inside the bracket just like this. And it will multiply with the 2, right? So this is already at its prime factor. I'm just going to rewrite it down like this, all over. And when we get to the denominator, what we have is 10. 10 is not already in its prime factor. And if we break it down, we know that will be 5 times 2, right? So we're going to put this inside the bracket and raise it to the power of n minus 1 times 27 is the same. It's not in its prime factor. We know that 27 can be written as 3 to the power of 3. And we put the exponent inside the bracket, and ta-da, that's what we have. So now from here, it's just a matter of simplifying everything. So if we try to simplify everything, we know that in the numerator, we're going to have 3 to the power of 2 multiplied by 1, which will give me 2, and 2 multiplied by minus n, which will give me minus 2n, right? And obviously that will be rewritten as it was. There's nothing that's going to change there. And on the denominator, sorry, we have 5. And remember, I don't remember what law it was. If we have something like this, 2 terms, obviously raised to the power of whatever, we need to take this exponent outside and distribute it amongst the 2 terms. So what I mean is we're going to have 5 minus 1, 5 to the power of n minus 1 times 2 to the power of n minus 1. And then obviously with the last term, we have 3, and 3 will multiply the 1, which gives us 3, and it will also multiply minus n, that will give us minus 3n. So these are basically all the values that we have, right? And if we simplify that further, or if there isn't anything to simplify, then now we can start introspecting how can we go about solving this. So now, how do we go about solving this? So we now will look at the terms that we have that are similar to the ones at the numerator and the denominator. So what I mean with that is, I see that 3 to the power of 2 minus 2n, there isn't any value at the bottom that's the same as it. I know that there's 3 here, and I'll solve it accordingly. But when I look at 5n to the 5 to the power of n minus 1, when I look at this value here, I see that it's the same as this one. And since obviously this one exists in the numerator and the other one exists at the denominator, they can always cancel out, right? So those two cancel out, and what I have remaining at the numerator is 3 to the power of 2 minus 2n. So now I take the one at the denominator, and as I said, if we're dividing powers that have the same base, we subtract the exponents. So I'm just going to subtract the exponents in this case. So I'm going to say minus 3 minus 3n, which are the exponents of the 3 at the denominator, right? So what I have remaining at the denominator is 2n minus 1. It doesn't really have a pay, so I'm just going to rewrite it like that. So now if I simplify this further, I'm going to have 3 to the power of 2 minus 2n minus 3 plus 3n all over 2 to the power of n minus 1. And if I simplify that further, I know that 2 minus 3 will give me minus 1, but I don't want to start with 1. I'm going to start with minus 2n plus 3 will give me n, and then the minus 1, I'm going to write it after, and I have 2n minus 1. So can I simplify this any further? No. So this right here will be my final answer. So that is it for this video. If you really want us to tackle more examples, please just comment and send us more examples on our email at hello@aswtutors, and we can get to look at those examples and probably make a video out of them. But that is it for this video. Please don't forget to like, share, subscribe, and tell your friends about it. See you in the next video.